If f is a function defined by y equals f of x, then the derivative of f of x at any value x, denoted f prime of x, so this reads as f prime of x, is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h, if this limit exists. F prime of c exists. If f prime of c exists, we say that f is differentiable at c. So example 4 wants us to find the derivative of the function f of x equals 3x squared minus 1. So f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So I want to calculate the components. So f of x plus h is equal to, anywhere we see an x, we want to replace it with x plus h. Okay, so we have f of x plus h equals 3 times the quantity x plus h squared minus 1. And I'm going to go ahead and write that out. So I want to FOIL or expand x plus h squared. So if I do that, that gives me x squared plus 2xh plus h squared minus 1. And then I'm going to go ahead and distribute the 3 in. So that gives us 3x squared plus 6xh plus 3h squared minus 1. Okay, so now we come back over here and we say that this is equal to the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 1. Now be very careful. This represents f of x plus h, and we want to subtract off f of x. And students will often mess this up algebraically because you're subtracting off the whole quantity f of x, and you have to end up distributing that negative sign. So be very careful at this stage. Okay, so now I'm going to go ahead and rewrite the limit as h approaches 0, and I'm going to simplify the numerator. So if I distribute the minus sign here and the minus sign here, then we'll get 3x squared plus 6xh plus 3h squared minus 1 minus 3x squared plus 1 all over h. Now notice that some stuff is going to cancel out. So this 3x squared and this negative 3x squared will make 0, and then the minus 1 and the plus 1 will make 0. So this is equal to the limit as h approaches 0 of 6xh plus 3h squared all over h. And we can factor out an h in the numerator. And if we factor out an h in the numerator, notice that this h and this h will divide out. So we'll be left with the limit as h approaches 0 of 6x plus 3h, and because that's a polynomial, we can just plug in h's, or substitute in 0 for h, so we get 6x plus 3 times 0, which just ends up equaling 6x. So after all of that work, we have come to the conclusion that the derivative function, or f prime of x, is equal to 6x. And so we want to box our final answer, and we are done with this example. Suppose that the total revenue function for a product is given by R equals R of X, where X is the number of units sold. Then the marginal revenue at X units is MR bar is equal to R prime of X, which equals the limit as H approaches 0 of R of X plus H minus R of X all over H, provided that this limit exists. Note that the marginal revenue, which is the derivative of the revenue function, can be found in a similar fashion to the previous example. Example 5 says, suppose that Mr. Kwan's boba stand generates revenue in thousands of dollars given by the equation r equals r of x, which equals 100x minus x squared, where x is greater than or equal to 0, where x is the number of thousands of units of boba drinks sold each day. Part A says, find the function that gives the marginal revenue at any value x. So we would like to find the marginal revenue function, which is equal to the derivative of the revenue function. And that can be found by taking the limit as h approaches 0 of r of x plus h minus r of x all over h. So let's come down here and evaluate r of x plus h. So that's going to be 100 times x plus h minus x plus h squared. And that is equal to 100x plus 100h minus, I need to expand x plus h squared, so that gives us x squared plus 2xh plus h squared. And now I want to distribute that negative sign in. So I get 100x plus 100h minus x squared minus 2xh minus h squared. Okay, that was a long process. These problems are long, but just keep at it. So we have the limit as h approaches 0 of 100x plus 100h minus x squared minus 2xh minus h squared minus the original function, which is 100 minus x squared all over h. So that equals the limit as h approaches 0 of, I'm going to cancel out some stuff, so I am missing an x. This should say 100x right here. Okay, so now that makes sense because this 100x minus 100x there, and this x squared and this minus negative x squared will cancel out. And so we will be left with 100h minus 2xh minus h squared all over h. Now, I'm going to give you a tip or a hint. I knew that I made a mistake earlier and did not include this x because whenever you're calculating the derivative using the limit definition like this, you're always going to be in a situation where this h needs to disappear. And the only way that's going to happen is if every term in the numerator has an h. And so if you're left with something like plus 100x, that doesn't have an h in it, and so that's not going to make the denominator disappear. So that is how I knew that I made a mistake earlier. So now every term in the numerator has an h in it, so I can factor out an h, which will leave me with that. And now this h and this h will divide out. So again, whenever you're doing the limit definition of a derivative, the h in the denominator is always going to cancel out. So if it doesn't, that means that you did something incorrectly. So then that equals the limit as h approaches 0 of 100 minus 2x minus h. And if you substitute an h, that just ends up equaling 100 minus 2x. So our marginal revenue function, or r primed of x, is equal to 100 minus 2x. Find the marginal revenue when 20,000 boba drinks are sold. That's another way of saying when x is equal to 20. So we are basically calculating r prime of 20. This is the, remember, r prime of x is the derivative function. So we want to plug in 20 into our derivative function, and if we do that, we get 100 minus 2 times 20. That's 100 minus 40, which equals 60. And remember, this is in thousands, so this is $60,000 per 1,000 units. So how do we interpret that? That means that because the marginal revenue is used to approximate the revenue from the sale of one additional unit, that means that the expected revenue from the sale of the next 1,000 boba drinks will be approximately $60,000. So again, that's to say that the revenue from the next 1,000 boba drinks will be about $60,000.